Hello everyone and welcome to another video. On top of my existing hobby, which is RC drones and RC wings and planes, I've recently taken a very interesting new hobby, and it's been taking a substantial amount of my time. So I thought of why not share this hobby with you. Maybe it's something that you're also interested in. So I've basically taken this hobby of military flight simulation. What you see here on the screen is a software called DCS, or Digital Combat Series. DCS is a simulation software that is designed by a company called Eagle Dynamics. And it's basically a digital combat simulator environment. So they create an environment where you can plug in modules, and those modules could be like combat airplanes, they could be tanks, they could be helicopters, and those are used in this digital combat environment to play simulated battles. So in my case, what I do is I fly the US Navy A-18C Hornet, which is a multi-role fighter. It's designed for air-to-air and air-to-ground missions. You can see an image of, or basically you can see how this plane looks like here on the screen. It's been with the US Navy for quite some time now, and there has been multiple iterations, and the recent is basically the F-18 Super Hornet. The one that is simulated in this digital combat environment is the F-A-18C Hornet, which is Lot 20. And again, it's a multi-role fighter designed for to work off an aircraft carrier, and it's designed for basically air-to-air and air-to-ground combat. It can carry a host of weapons, long range, short range, air-to-air missiles. It can also carry laser-guided bombs, laser-guided missiles, TV-guided missiles, GPS-guided missiles, a huge array of weapons. And the nice thing about this software is that all those are authentically simulated. As you will see now, the cockpit is also simulated down to each and every button and function. So all the navigation systems are simulated, also target acquisition systems, weapon delivery systems. And this video today is kind of an introduction where I want to introduce you to the plane and show you how to start it from a state where it's cold and dark. So we take a plane that is totally switched off, it's off, and then we start it up or turn it on from scratch, and take it to the runway and then take off. So without further ado, let me go ahead and start. I'm going to go to the mission editor and I will basically load a mission. This mission, I've placed my F-A-18C Hornet in an airfield called Kanskaya. Let me zoom out. This region is basically called the Caucasus. It's very close to Russia. It's a very interesting environment, full of mountains and hills, and it's on the coast. So I've placed the F-A-18 here on an airfield, and it's in a totally dark and cold state. I'm going to start it up, then I'm going to taxi to the runway, and then I'm going to go ahead and take off. So let me go ahead and load the mission. Okay, so as you can see, I'm sitting now in the cockpit of the F-A-18. Even the canopy is open. It's totally switched off, and I'm looking around. I'm using a head tracker, so as I move my head, I can basically simulate the pilot's head movement when looking at the environment. So to start with, to start with this procedure, or the startup procedure, The first thing you do is you switch on the main battery, which is here. So I'm going to right click and switch on the main battery. And this main battery is used to power up an auxiliary power unit, or called the APU, which is this unit here. The APU is basically used to start spinning the turbines. So when you spin the turbines, you basically give them a momentum until you inject fuel in them, and then you ignite the fuel and the turbines start spinning on their own and become self-sustaining. But we don't spin both turbines at the same time. We start by spinning the right turbine or the right engine for a reason that I will discuss later. So let me go ahead. So I switched on the main battery here. Then I'm going to go ahead and switch the APU unit on. You can see the APU, you can hear the APU spooling up. And then I'm going to wait until this green light turns on, and that means that the APU is ready. And after that, I will start by cranking the right engine. So now the APU is ready. I'm going to go ahead and I'm going to move the switch to the right, which is the right engine. And as you can see here, the right engine is going up. I mean, the RPM is going up, but there's no fuel being injected. As you can see here, it's 0, and the temperature is still the ambient temperature of 18 degrees Fahrenheit. At 28 or 27% RPM, I'm going to go ahead and I'm going to move the right engine throttle from off to idle. This would inject fuel. As you can see, the fuel flow is going into the right engine, and the temperature is going up, and the RPM starts to build up until the right engine idle state. Idle is between 65 and 70% RPM. So as you can see, the right engine is now on, or is now up and running, and it's fully sustaining itself. So I'm going to go ahead and move the switch to the left engine, and the same thing here. The APU is spinning the left engine, so that the temperature is ambient and there's no fuel flow. I'm going to wait until it gets to 25% RPM, and then I'm going to go here and I'll move the left throttle from off to idle. And then the same story here, the temperature starts to build up, fuel is being injected and ignited, and the engine starts to basically spool up to idle, which is around 65 to 70% RPM. So the next step would be, I mean, it's very noisy here. I'm going to close the cockpit. So I'm going to pull the switch down. And as you can see, the cockpit is closing. It's fully closed now. I'm going to go ahead and switch on the oxygen to the pilot mast through this switch. So oxygen on. The next thing to do is to test the fire alarm circuits. And we do that using this button here. We have two circuits, circuit A and circuit B. I'm going to start by testing circuit A, and when I do that, you'll see that you will hear audible alarms. So let's go ahead and pull the switch forward, or push it forward, to hear the audible alarms and make sure that the fire alarm circuits are working.
Engine fire left. Engine fire left. Engine fire right. Engine fire right. APU fire. APU fire. Bleed air left. Bleed air left. Bleed air right. Bleed air right.
Okay, so we've tested circuit A, and I can do the same thing for circuit B, but I'm not going to repeat that. I'm not going to do that because it's just a repetition of the alarms that I've just heard, which means that the alarms are working. Now, when we do that, we have closed the bleed air valves for the engines, so we need to reopen those valves, and we do that by rotating this knob, which is bleed air, 360 degrees clockwise. So I'm going to rotate it, and the valves are reopened. Next step is, I've mentioned when I started that I start basically by cranking the right engine, not the left engine. The reason is, tied to the right engine is an electrical generator that powers all my displays and powers the radar and the other systems in the Hornet. So now we have power that we can use to power up my screens and my other systems, navigation systems, radars and other systems in the Hornet. So I'm going to go ahead and switch on my left screen called left DDI, and then I'm going to turn on my right DDI. I'm going to turn on the heads-up display by rotating this knob, and I'm going to turn on my multi-purpose color display, which is here like this. So now all those screens are turning on. The next step, and as you can see also the HUD is on now. So the next step for us is basically to synchronize our inertial navigation system. The INS, or inertial navigation system, is the system that helps the Hornet to navigate throughout the geography, and it also has gyros that enable the airplane to know its attitude, its angle of bank, So we do that by basically this knob. You see it's labeled INS, and because I'm on the ground, I'm going to move this knob to the ground position like this, so it knows I'm doing an INS synchronizing while the plane is on the ground. It's not an aircraft carrier. And what I'm going to do next is I'm going to go to menu on my right DDI. I'm going to switch on to my HSI, or horizontal situation indicator, and then I'm going to click on stored heading. The reason is synchronizing the INS is going to take up to 8 minutes unless you have a point that is stored in the engine flight computer, and that point is used as a reference or to basically to resynchronize the INS. And in this case, the whole resynchronization process would take only 1.5 minutes. And I do that by clicking STD HDG, which means stored heading. So now my inertial navigation system is synchronizing, and as you can see, there's a countdown timer, and when it goes down to around 5, the INS would show OK here, and it's basically synchronized. The next thing to do now is I'm gonna switch the hook bypass to field, because I'm taking off from a field, not an aircraft carrier, so I'm not going to use the hook. I'm going to switch the flaps to half, because when you take off with the Hornet, your flaps should be in the half position. I'm going to go basically also to the right hand side. I'm going to uncage my ADI. I use the ADI to basically know my attitude, and I'm going to set my radar, my altimeter or radar altimeter warning height. Usually when we're taking off from an airfield, we set this alarm to 200 feet. So whenever I go below 200 feet, you will hear this alarm or sound. The next step to do after doing that is, I forgot here to switch on my radar, so I'm going to also switch on my radar, put it in operational mode. It will still be off because there is pressure on the wheels, so it's not going to switch on and microwave everybody on the ground. The next step basically would be to start working on, let me check what the next step is. Yeah, it's basically the flight control surfaces. So this aircraft was off, and the flight control surfaces, which we know in RC as the flaps or the elevators or rudders, they need to be reset. So I'm going to click menu, I'm going to click FCS, which is flight control surfaces, and you can see X's here, which means there's an error. So I do that by clicking, I reset those errors by clicking on the reset button here, and then all my moving surfaces are reset. And as you can see, I'm going to move them. You can see the aileron moving as I deflect my joystick. You can see also my rudder moving as I deflect my rudder. The next thing to do is when the Hornet is on the runway and taking off, the horizontal stab needs to be set at a certain trim, and this trim is based on the weight of the aircraft. So we can check the weight of the aircraft here. I'm going to click menu, I'm going to click menu again, and then checklist. And on the checklist, you will see the total weight, which is around 37,000 pounds. And if my memory serves me correctly, it's the default. I have to put the horizontal stab on the default trim, which is 12 degrees. So I'm going to go back to the FCS page, and you see that the horizontal stab is at 0 trim. I'm going to click this button, rudder trim, and you see it's now set to 12 degrees horizontal stab trim. So that takes care of the FCS or flight control surfaces and the horizontal stabilizer trim. I'm going to go back to my INS synchronization, and you see that it shows here OK, which means it's been synchronized. So I'm going to go ahead and put the INS on IFA, which means it's in a stable synchronized position. The next step would be basically to simply arm my ejection seat. So in case something happens and I need to eject, the ejection seat is ready. I'm going to tighten the straps here, and then the plane is ready for takeoff. So what I'm going to do as a final step is I'm going to release the hand brakes, and I do that by releasing this knob here. It's released, and now I'm ready to taxi to the runway and take off. So I'm going to go ahead and push my throttle a little bit forward to start building up, speed, and I'm going to turn to the left towards the runway. And I'm going to start taxiing to the runway. So the procedure when taxiing the Hornet is not to exceed 72% RPM. So that is why you see me managing my throttle here to make sure I don't do that. I don't exceed 72%. So I've reached here the edge of the taxiing area, and I'm about to enter the runway. Of course, I'm not going through the communication procedure with the tower, because when you want to take off, you need to basically first obtain approval to switch on the aircraft, and after the aircraft is on and ready, you have to obtain approval to taxi to the runway. Obviously, this is just a basic video. I'm not doing that here. So now I'm at the edge of the taxi area, and I'm basically moving into the runway. So I've centered the aircraft, and I'm basically applying my wheel brakes. I'm back to a total halt. So the process to basically take off is I need to hold the wheel brakes and spool my engines up to 80% RPM, and then when I'm at 80% RPM, I would release the brakes and then go full throttle, or even after the burner if needed, in case the weight of the aircraft is high. In my case, I don't need to. I don't have any weapons loaded, no external tanks. So I'm going to basically just hold the wheel brakes. I'm going to spool up to 80% RPM. And at 80% RPM, I'm going to release and push full throttle. And as you can see, the aircraft is rolling. At around 140 knots, I'm going to pull up on the horizontal stabilizer to take off, and the airplane would take off smoothly. Now I'm off the ground. I'm going to basically go gear up, flaps auto, and the plane is up and running. I'm going to keep, climbing at around 5 degrees, and I'll maintain a speed of around 300. I hope you enjoyed this video. This is a really interesting hobby, and I'm planning a next video of how to land. So this takes care of, you know, starting up the aircraft, taking off. Of course, I didn't go through some complicated instrument startup, like for example, there's like weapon systems here, like the, you know, the radar, the electronic warning system, the radar warning receiver, stuff that I didn't go through, as this is just, you know, a basic introduction and, you know, teaching you how to start up the aircraft. But this is something I can definitely do in later videos if you show interest in this and if you want me to do it. My plan is to have another video that shows basically how to land and what's the exact landing procedure on an airfield. I'll post links in the description around where to download a DCS or Digital Combat Series, and you know, if you're interested, you can do that. It's a free download, and it comes with a couple of free aircrafts that you can try. And this aircraft that I'm flying here is a paid module that you need to buy in Canadian, maybe around 60 or 70 Canadian. So I hope you enjoyed it. Please, if you've liked this video, click like and subscribe, and please leave in the comments section anything that you would like me to go through in future videos. Maybe you want to go through the weapon systems, you want to go through you know, how to deploy weapons, how to acquire targets, and I'm planning on doing those things. You know, I just want to take it step by step so that, you know, I can take a beginner from scratch, from knowing nothing, until, you know, he's at an advanced stage. So thank you again, and have a nice day. Bye bye.